Okay, so it says when two inequalities are put together, they form a compound inequality. That's what we just talked about. So I told you we're going to talk about and or problems. The first type we're going to talk about is an and problem. So it says if a compound inequality uses the word and, it is true if both inequalities are true. Its graph is where the graphs of the two inequalities overlap. This is called the intersection of the two graphs. So y'all know what an intersection is. Think about like roads. What's an intersection? Like with streets. What is that? Where they combine, where they cross. Okay, where they meet, where they cross. So think about you're going to have two graphs. Like say you have one going this way and one going this way. It's going to be where they overlap, where they cross each other. That's going to be your answer. So this first type we're looking at is an and problem. You see how it's written together like this? Negative 3 is less than or equal to 3x plus 6 is less than 12. The only time that they can be written together like this is if it's an and problem. I would write that note on your paper. Problems can only be written together if they are and problems. So if you see something like this where it's all squished into one problem, the first thing I do is I go ahead and separate it. So you see on the way to write the first one is we have negative 3 is less than or equal to 3x plus 6. You write the whole thing that's in the middle. And then your second one is the whole thing that's in the middle and the right side. 3x plus 6 is less than 12. So then you have 2. And you do want to actually write this word and in between. Okay, so on your own, go ahead and solve both of these. Okay, I would not write your answer in step builder notation yet. I'm going to show you how to do that in just a second. So you should get negative 3 is less than or equal to x, then x is less than 2. Remember how we kind of used this little arrow to figure out which way to shade on our graph? You know what I'm talking about? They're like points in the direction you need to shade. Remember, the variable has to be on the left side for you to do that. So what I always do is I rewrite both of them with the variable on the left side. So this one it already is, but the first one it's not. I'm going to rewrite this as x is greater than or equal to negative 3. It's opening towards the x, so I kept it opening towards the x. So we're going to graph both of these on this same line. The first one we're going to use to kind of come up with our answer, and then the second line is going to be our final answer. So I need to number this, that way -3 and 2 will both fit on here. So I'm going to use my first color for x is greater than or equal to -3. So that's going to be a closed circle at -3. And then do I shade to the left or to the right for that one? The right. Okay, now for my second inequality, I'm going to use my other color. X is less than 2. And I'm going to graph this right on top of it on the same exact graph. So it's going to be an open circle at 2. And then I shade to the left. So I'm going right on top of that red. So I'm going to write a little note over here just to remind us this is an AND problem. That means my answer is the intersection. So what am I going to graph for my final answer? Where do these two lines intersect? It's going to be everything in between -3 and 2. All that space in between. So still keep it a closed circle at -3 and an open circle at 2. And then everything in between. So this right here is my final graph. So as you do more of these, you're not going to have to make 2 graphs every time. This first one I just showed you, that way you can see where the answer comes from. And if you wanted to make 2 graphs every time on your homework, you can, but I'm not requiring you to. If you can just jump to the final graph, then that's fine. So we still need to write our answer in step builder notation. For AND problems, there's actually 2 ways you can do this. The first way, we say for all x is greater than or equal to -3, and we write the word AND, x is less than 2. So if you remember back towards the top of this paper, you wrote this little note, problems can be written together if they are AND problems. We can go back and kind of squish it together like this. You write it going from left to right on your graph. So we say -3 is less than or equal to x, which is less than 2. So both of these are correct answers. Just know if you're writing it the second way, always go left to right. And these are always going to be either less than or equal to signs if you're going from left to right. Okay, any questions on the AND? or. Okay, so if a compound inequality uses the word or, it is true if at least one of the inequalities is true. Its graph is the union of the graphs of the two inequalities. When I say union, I mean they completely combine, like everything from both graphs you put together. So for unions, you graph everything. Okay, and I'm going to put in parentheses, not just the intersection. So, and problems, they can either be written squished together, like the last one, or they can be written and actually have the word and. There's only one way to write or problems. You're always actually going to see this word or. Every single time you'll see that word. Go ahead and try to solve both of these. Don't graph yet, just solve. Did everybody flip their side? So you should get A is greater than 7 and A is less than or equal to 2. So I need to draw my number line where I can put both of these on there. So I'm just going to start at 1. So in my first color, I'm going to graph that A is greater than 7. So I'm going to have an open circle at 7, and then I shade to the right. Okay, so now I'm graphing A is less than or equal to 2 in my other color. So what type of problem is this, and or or? Or. Okay, so this is an or problem. That means I graph everything. I know we already wrote that. I just think it's a good reminder to have right beside your graph. So for my final graph, it's really going to look just like the other one. It's going to be exactly the same because I'm graphing all of it. So as far as set builder notation goes, do you think there's one or two ways to write this? Remember the and, we had two options of how we could write our final answer. What do you think about the or? It's just going to be one. Remember, we said and is the only time you can squish them together, or you got to keep them separate. So I'm going to say for all A is greater than 7, or, I have to write that word or, A is less than or equal to 2. So just like I said before, every single time you don't have to do 2 graphs. You're going to get to where you don't need that. It's just good to figure out where your final graph comes from. Okay, the last bit is talking about word problems. This is just a little helpful hint right here. It says when solving problems involving inequalities, if you see the word within, that's meant to be inclusive. So that means you're going to have the or equal to's. But if you see between, like between 2 and 5, that's not inclusive. So that means no or equal to. That just may be something you want to look back at later. Okay, so it says a movie ticket for a child younger than 13 costs $5.95. A movie ticket for an adult 13 to 64 costs $8.95. And a ticket for a senior citizen 65 and older costs $5.95. Write and graph an inequality that describes the ages of the people whose tickets cost $5.95. Okay, so reread it to yourself and figure out whose tickets cost $5.95. Jennifer, what's one group that pays $5.95? Okay, and what's the other group that's going to be charged $5.95? Lily? The kids. Okay, so we need to make sure we can figure out, do I use the or equal to when I'm writing these? So it says a child younger than 13. So if it's younger than 13, does the 13-year-old pay $5.95? It says younger than 13, so that doesn't include the 13-year-old. So you're just going to say A is less than 13. So, and then a senior citizen 65 and older. So that includes the 65, but greater than or equal to 65. So there's 3 graphs here. I think originally I graphed the greater than 13, or I'm sorry, less than 13, greater than or equal to 65, and then put them both together. We don't have to do all that. You can do it on one. So sometimes the hardest part on these is, on the word problems at least, is deciding if it's going to be an and or an or problem. A lot of the times it's really just common sense. Okay, think about like one person. And can one person be less than 13 years old and greater than 65 years old? No, it's going to be or. Okay, because they can either be less than 13 years old or greater than 65 years old. It can't be both. So this is going to be an or problem. I'm actually going to count by 13s on my graph because 65 is a multiple of 13. I know that's kind of weird. Okay, so less than 13. Okay, less than 13, then that's going to be open circle at 13, and I shade to the left. And then greater or equal to 65. It's going to be a closed circle at 65. and then greater.